Welcome everyone to this new vlog series where we will explore together how to solve the web hacking labs on the SQRSEC platform. This vlog series is ideal for people who are not ready to solve the labs by themselves or who want to understand better what is the reasoning process behind solving these challenges. Before we get started, be aware that there will be a lot of spoilers on how to find the vulnerabilities and how to solve the lab. So if you haven't tried this by yourself, give it a try first, and if you get stuck, you can come to this and take a look on how to move forward. So in today's lab, we will focus on broken access control, and we will collect 3 flags. We will start by doing initial discovery and recon. We will see how to parse logs and how to uncover clues, like where we have to move forward from the logs. We will combine 2 low-level vulnerabilities into a higher impact one, and we will see how old or forgotten infrastructure can still expose the system. For example, in our case, we will see how an old infrastructure enabled us to elevate our privileges from a low privilege user to something like moderator or admin. So without further ado, let's get started. If you are a member of the SQRSEC platform, you can come to the website and then navigate to your profile, go to the products options, and then you will be redirected to see all your products. If you are subscribed to the Pentest Tips and Tricks newsletter, then you will also have access to the web hacking labs, but you can just join the web hacking labs without being subscribed to the weekly newsletter. So we will go to the web hacking labs, and we will start with the first lab. Here we can find the URL where the lab can be found. We can see that the difficulty is medium, and there are a few notes and objectives for this lab. The notes are quite important, so you don't waste your time on things that maybe are not relevant. For example, no password or account brute force is usually needed on any of the SQRSEC labs. We don't see these vulnerabilities as something too advanced, so we usually consider those out of scope. And there is no need for you to try those. And then if you find any cross-site scripting, this might be by accident, and usually it's not relevant for the challenge that you are trying to solve. And lastly, you don't have to do any port scanning or anything like that. The whole application and everything that you need will be on port 443. So these are mostly web application and API challenges. They don't focus on the infrastructure and the underlying server. And then for the objective, for this lab, we have to retrieve 3 different flags, and the flags are in the format of SQRSEC flag, comma, and then UUID. So this will be quite hard to guess if you don't know them. Yeah, let's go to the platform itself and log in. If you already have an account on either the web hacking labs or the Pentest Tips and Tricks, you should have received an email with all the details for your account. So navigate here and then log into your account. I have already logged in, but I will log out just to show it. SQRSEC labs, and once you log in, you should be redirected to the challenges page, and we will start, as I said, with the lab number 1. You have the same details that you already had on the main SQRSEC page. Here we can see how to submit the flag. If we have 3 different flags, we just separate them with a dash, and the target is over here. And just an important note, the lab is behind HTTP basic auth, so you will have to use the same username and password that you just logged into the labs platform to access the lab. So I'll navigate here, and it will prompt me for credentials, and it's the same that I have used for this platform over here. So okay, now that we have logged in, this is the application, the targeting scope that we have to find the flags inside it. I will close the other tabs, and I will turn on the proxy in the browser just to see all the traffic. So we proxy through localhost 8080, and close. I will refresh the page, and then we go to Burp, and we should be able to see the request to the lab01 squaresec.com. I will delete this one and we can see a lot of traffic from Firefox. So I will add this in scope and make sure to not see the other ones. Okay, so now we only see our target application that is in scope in the Burp. I'll go back to the browser and we can take a look here. Usually the easiest one is to view the page source to see if there is anything interested. We can see some the fav icon, we can see some fonts, not anything interesting, style sheet, CSS, nothing that it's usually interesting. We can see a path to a image here. Maybe we can try to find other files here, and we will do some file and folder enumeration later to try to discover more content. And then we can see that there is just a simple post form that will send the username and the password. There are no hidden fields, there are no hidden actions or hidden paths. So it is a very basic form. I'll close this. And first thing that I want to do in this case is try some random credentials, or we can try some default ones and see if we get any hit. But most important, you want to see how the application handles those credentials. How does the request looks like when you submit the form, and let's see how does the application handle some unexpected input, like for example if we fuzz the username and the password, does it throw back some errors that we can find more about the application from it. So I'll go with something like admin, say login, and it says that invalid credential. So let's see how this looks in Burp. We can see that there is a post which is also to the root domain, and here we have the username and the password, admin, everything that everything looks as we expected. In the requests, we have an authorization, but this authorization is related with how the SQRSEC platform is used. Those are the base64 encoded credentials for your account, so this is not something related with the challenge itself. It's just to protect the challenge from the internet access. And then we have some cookies. Let's try to see if we can have a PHP Session cookie. Let's try and see if we can delete those and if we get some different information from it. So let's send this to repeater. Send it again. And in this case, we have the invalid credentials also in the error part. So I will start by deleting the cookies and see if I get any type of error back. Everything looks quite the same. Let's try to delete those as well. Looks the same. Content type, user agent, nothing quite interesting. So I'll send this to intruder and try to play a bit with some random fuzzing inputs just to see how does the application handle and if it throws more errors. So sending this to intruder, and I will add the injection points in the username and in the password, and I'll use the simple lists, and I will load something that Burp already has. So I like to go with fuzzing quick and fuzzing full because those already include some payloads for SQL injection, for SSTI, some basic payloads, command injection, and something that you need for quick checks. This is a very small list, just 39 payloads, so I will add also the fuzzing full one. But you can of course always go with more fuzzing lists. I like to start with something small just to see if the application throws some error. So let's start with this, see if we get something. I'll sort by the status code to see if we have something like a 400 or 302 redirect in case we hit something abnormal. Okay, so this has finished. We have tried to fuzz both the username and the password and see if we have any interesting status codes. It looks like everything is a status code 200, and then in the length, it seems that all the lengths of all responses return the same length. So we can check a few of them just to see if there is something different. But usually when the status code and the length is the same for all of them, it means that the same type of response has been returned for all of them. So we can just we can just double check that invalid credentials. What we can do is try to search for these invalid credentials and do a reverse check on this, a negative search. And if one of the responses does not contain the invalid credentials one, maybe there's something interesting there to look into. So I will apply this filter, and now we can see that no response has been found to not contain the invalid credentials. So all responses contain this invalid credential. So at this point, we can be quite sure that since all of them return invalid credentials and all of them return the same status code and the same length, pretty much nothing was found as a result of this quick fuzzing. So I will close this for the moment, and let's try to see if we can find some interesting paths. For example, you try to find something like /admin or maybe /portal. So let's use a quick fuzzing list to see if we can find something more interesting, because when we look in the page source, we can see that there is a fav icon, and in the CSS there is a PNG file which is also hosted here. So we can go directly to this one. But of course this is just an image, so it's nothing interesting here. Yeah, this is just the background image, but maybe we can find a page or something that is hidden over there. So let's close this and we go back to Burp. I will select the get one and I'll send this to intruder. So let's select this as injection point. I'll use again a simple list. I like to use quick hits from the sec list first, because this one has quite a lot of good paths that return only some nice things, and it's also quite a small list, so you can finish quite quick with it and find some good stuff. And if nothing comes as a result of this, we can go for something more large, like rough large directories or files, or let's see what else we have here. Yeah, raft medium are usually pretty good ones. So but let's start with the small one first. So I'll open this one. We have like 2000 payloads, so let's send this and see what we get back. Since that is hanging, what's happening here? Oh, so let's pause this for a second, and we can see if we look at the baseline request, this one has a slash, but if we look at the payloads that we have sent, the slash is encoded, like URL encoded, and the server does not reply to that. It considers it like a valid format. So what we have to go is we can cancel this one, and we have to scroll down and make sure that in the payload encoding we have to remove this one. In most of the lists, when you do file folder enumeration, you don't have the slash, and the slash is already there, but in this case we also encoded the slash because it's in the list itself. So this time I had to disable the encoding to make sure that the server replies properly. So let's start this attack again, see if we get something. So if we look again, now we can see in the payload that the slash is not URL encoded anymore, and now we get a 404 return from the server. Let's see if we have anything here. It's just a default not found page, nothing interesting. I'll let this to run, and once it finishes we can analyze the results. Okay, now that we have finished running the quick hits list, let's see if anything interesting has been found. I will start by sorting by the status code. Let's try to do it this way, and we see a lot of 404, which usually doesn't return anything interesting. So what I like to do is remove the 400 codes from the filter, from the view, So you just uncheck this and we apply the filter. Now we have a few, we have less results to go through, and we still have quite a lot of 200, only 200. Let's do some other thing. Let's sort by length, and we can see that it has found something that stands out compared to the regular results. The regular ones have a length of 2434, and what we have here, we have the regular login form. If we render this one, it's the regular page that we have seen many times, so it's quite similar with the baseline. But we have one which is a Docker file, and we have one which is a Docker Compose YAML, which are quite you may find them by accident pushed by developers to the production. So let's see if we can find something interesting, maybe credentials or something here in the Docker file. We can see what is the base image used is PHP 8.1 CLI, so it's good information to have on what type of programming languages is the application using, and if there are any vulnerabilities related with PHP 8.1 CLI. So it's good to make a note of this. And we know the working directory of the application, which is var tab and HTML, quite common. But if we have something like arbitrary file read, or we need to save a file to outside this directory, we at least know like where we stand and how to move around this. So it's good information to have. It's using port 80 for the application, and then the command is php /s, and then it's exposing to all interfaces on port 80. So let's take a note of this one. So /docker file, we will use cherry file for this. And I have created a project here. I'll add a note, let's say enumeration, and in the enumeration let's say /docker, and I'll paste the content of that one, and let's see what else we have found. We have a Docker Compose, version 3.9, not that interesting. The name of the lab, port that is being exposed, is instructed to restart if it encounters any kind of error, and then we can see that the memory limit is quite low, so it might be possible to do a denial of service on this, since the resources allocated for this lab is quite low. But then again, denial of service is not usually something that we try to do in this kind of labs. We try to find a flag, so just performing a denial of service won't get us anywhere. So, but let's save this information for later, and maybe we can use it at some point. So this is in /docker compose. I will save the request and the response. Okay, and the response. And let's see if we have found anything else. We see a lot of default ones, so maybe we can hide those. Don't see a way to hide based on the length, but let's scroll faster. 2434. Oh, and then we have something which is quite large, which logs, access logs. In the response, we can see that there are quite a lot of many paths, IP addresses, dates when it was accessed, quite old ones. You can see that there are a lot of paths which we can also try to access, something related with Kibana, some images. We have some JavaScript files that might, for example, contains hard-coded credentials. We have some different domains. Have the browser that it was used to access it, and that's pretty much it. So we have quite a lot of those logs. Let's scroll to see if we can find anything interesting. It's quite hard to go through all of them, but we have around 10,000 lines of logs. So in this case, it's better to do some kind of grep or regex, or try to look for something interesting in this, because looking manually to 10,000 entries, it's quite boring and it takes a lot of time. So let's copy all this. I'll put it also in cherry tree. What is the path for this? Logs, access, logs. So let's copy this and paste it here. Well, it turns out that cherry tree doesn't like to have such large files such large contents in its files. So we'll skip this part. I will just write down the path where we found it, and in case we need it, I will just access it from Burp. So the path was logs, access logs. Okay, and what we can do in the meantime while we analyze these logs, let's send this to repeater just to have it saved. Okay, and if you can go to the target, one thing that you can do here is to ask Burp to discover content for you. So in this case, you don't have to give a specific list. The Burp will look at what paths already exist in the Burp history or in the application itself, and then it will follow those paths and try to find new paths. So it acts like a spider and try to find all possible paths, and you don't have to rely on, let's say, luck to pick the right enumeration list or to find the right path. It will find those paths based on what the application already is exposing. So in this case, you can use the engagement tools and discovery content, and then we start the session, and we can see that there will be a site map, and Burp will add here all interesting paths that it will find. So something like /portal, we can see that it has already found, and let's try to render this one to see. It doesn't look like anything interesting, but it was still reported as 200, so I guess that's why it has been added. So let's have this enumeration and recon run in the background, so in case none of the files of the things that we have already found brings anything, we can come back to this and have something else to look into. So I'll just minimize this, and we can start to look into the logs and see if we can find anything interesting here. So first thing first, I will copy this and try to grab for some interesting hits. I'll go to Kali for this, and let's create a new file. And paste this content here. Let's hope this one doesn't crash. Okay, now that we have pasted everything here, let's delete those lines and keep on the logs and save the file and see word count. So we have 10,000 entries in these logs. So first thing first, let's try to see what format this one has to analyze it a bit better. So what we have is an IP address, and then we have a date, and we have a path, then we have status code, size, another domain, which is looking a bit out of scope for our lab, and then we have the browser. So if you want to discover more content, one thing that we can do is try to extract those paths that they're already listed here, and try to see if we can still access them. So the way we will do this is cut this one, and then let's cut by maybe by space. Let's look again. So what we have here, so we can see that the paths are surrounded by those double quotes. And what's nice about these logs is that they're already properly formatted, so I don't see any other quotes before this. There are some quotes after, but what we want to do is try to extract all those. So I'll do cat logs, and then let's use cut, the other cut, and we use as a delimiter the double quotes, and we have to surround it by single quotes, and then we have to get the first, let's see, the first, F stands for first entry, the second entry, the third entry, so we can play a bit like this, and you can see that if we pass F/2, it will get us the path that we want to extract from this file. This looks quite good. I'm just making sure that all things that we have extracted look like a path. This one looks pretty good. Let's see how many we have. Word count -L, so we have 10,000 lines, so we have for each entry we have extracted like a path. One problem that we have right now is that we still have this get space, and if we want to use this list in Burp Intruder to check the paths, we will have to remove this one. So we will use again cut for this, and this time I will cut based on a space, so I'll use a delimiter for the space, which is this space from here, and then I'll use /f, and first one is this part, which is before the space, and the second one is this part, and third one is this one. So if we say 1, we will get all the gets. If we say 2, we get all the paths, which is what we want. If we say 3, we get all the HTTPs. So in this case we want to use this, and just to make sure, let's count again to see how many are there. So again, 10,000. We have 10,000 of those, but one thing that I noticed is that we have also the status code here of 404. So just to save some time, I think it makes sense if we start first by ignoring those 404, and if we don't find anything, we can also include those 404s in the next search. So first we start with a small list which doesn't include the 404. Let's see if we have any 200 or any other status code. We can check this. Let's do a cat logs, and then let's grab negatively by 404. So we will ignore all entries that contain 404. We don't print them. No such file. Oh, cat logs. So now we see that we have some entries in the logs. This one returns a 301, status code 301, 304, 500. So we want to take a look first at these ones. So let's go back to this one, and let's ignore, we will read again the file, but we will ignore the files that contain 404, so surrounded by space. Let's do this. Okay, so these are the paths that didn't return any, that didn't return 404. So those are paths that either exist or do some returning, some redirect. One thing that I noticed is many of them are duplicates. So another thing that we want to do is sort/u, which will only give us the unique entries. And let's see how many we have now. If we count again the word count -L, we have only 267 entries. So now we went from 10,000 log entries to 267 paths that are not 404. So let's see if we can make this a bit smaller. For example, we don't really care about CSS files. Let's see if there is anything else that we don't want. We don't want to see PNG, we don't want to see JPEG, so maybe TFF, which is for fonts. We don't want to see those, so we can ignore them as well. Doesn't make a huge difference when there are so few, but if you have like a large list of paths, you may want to strip those out, so you save some time. So what we can do is do again negative grep with the grep/b, and I will include PNG, and then let's say CSS, and then JPEG, and then let's see how many we have now. We count them again, and we only have 148, so we split those in half, from 10,000 to 200 and now to 140. So I think we have made quite a small list that we can already try. So what I will do, I will copy all these paths and do a burp intruder again on these paths to see if we find anything interesting in those. Okay, I will close the previous one and let's go back to burp. Let's see if the discovery tool have found anything in the meantime. So if we go to the sitemap, we can see that it's still running, but we didn't discover anything. So I guess at this point we can still let it run. I will stop it and let's try to run intruder on this path that we just found. So I'll send this one again to intruder. I will set the path injection point here, and I will paste this new path that we just discovered. And as last time, we have to make sure that we don't do encoding on the first slash. So let's start this one and see what we find. Okay, now we have finished. You can see that there are some 500 errors. Let's see what that's about. Bad gateway, any length is different, so all of them are bad gateway, and all of them. So I will just ignore the 500s just to try to clean a bit these entries and just find something interesting into it. We have a lot of 404, which again doesn't give us anything interesting. This is the path that we just tried. Yes, this is the path that we just tried. So we can see that the length is just different because the server reflects our payload into it, but it's not different because we have anything different into it. So we have a lot of 404 and some 403. 403 access denied. Okay, this is interesting. Access denied for login.php. And then we have a 302. Let's ignore the 404 also. We are left with a 302, which does a redirect. 302 with the login.php, and we have a session here, which is interesting, and we are getting redirected. So let's try to see what's that about. And then we have a very large response. This is the favicon, so nothing interesting. Let's sort this by length. So what's different here? The favicon, not interesting. Those are the default ones that we have seen so far. So the login form, nothing interesting here. You can see that they are all the same length, so we can ignore them. And then we have this login PHP with a session. So let's try to open this in the browser and see where we get the redirected. So I'll copy this and let's do this. Oh, and you can see that the application was logging the session that was used to authenticate the users, and then we managed to find this session in the logs. And once we had the session, it already authenticated us with the account of that user, which in this case is Johan Doe. So this is something interesting. We have bypassed the login, and I'll make a note of the session that we have obtained and how we got the first user. So add subnote. It's not added here. Let's create a new subnote. PHP Session or user, say login bypass. Login bypass, and we have this path. Accessing this path authenticates as Johan Doe. And it's good to mention that we found this path here. So we case we need to report it, people will know where did we found this PHP session, so they know how to where to look for and how to protect it so it doesn't happen again in the future. So in this case, they would have to disable the logging of the session, and of course not paste the session ID inside the URL. So just found in logs, access logs. So now now that we have a login account, let's try to see what other things we can do here. So we have a logout button, and then we have some we have some messages, we have some IDs, we have some sender, we have some recipients, and some messages, which doesn't look like much. See if there is anything in the page source. So now we can see that there is much more than we had in the login form. You can see there are some JavaScript functions. You can see that there is a request to API profile PHP using the username as a parameter. There is some JavaScript code here. There is a post to API messages at PHP. There is also a function start hello, start debug. This might be something interesting to explore. Start analytics. This looks like something to do with Google Analytics. Start localhost request. This is quite this is something uncommon as well. I have a loop here. It sounds like these functions are running in a loop. All these functions are being started, and then we have a API/logout. So you see that there are a lot of new paths and a lot of new attack surface. What we want to do now is try to find as many new endpoints as possible and see what we can do with our new account and what permission does it have and where can we get from here. So at this point, what you want to do is start to repeat the process that you already did when you were unauthenticated, but this time you want to do it using the session of the logged in account and see how many more permissions you have. So if we go back to Burp, we can see that there are some requests here that go to debug and hello. So let's explore those to see what we get into them. Hello Johan, which is our user. Then we have a debug, which returns 404, so not much. You can see those are running one after the other in a loop, which can be quite annoying because it's producing a lot of traffic and it can be distracting from the actual testing that we want to do. But this is quite common in large applications where the application will send a lot of requests and you never have like a view where everything is static, everything is moving all the time, so you have to filter out those. So let's go to the target and try to remove those from scope, because we don't have much information out of those. We can start to filter out those that are not that interesting. So I'll go to the target scope, and we have to exclude from scope things that we are not interested into. Let's say this one. Like this. Okay, now we can see that it disappeared from here. So let's do the same for the debug, since it returns 404. Do the same. Okay, now we have way less traffic and things moving on. We have the get, we have the post, we have the /admin. This was something that we had before. /portal. This is the one that the endpoint that we use to get authenticated and to get the PHP session for us. We have the /home, which renders the page that we have already seen. Let's see if there is something in the raw response of that. So here we have the fetch for profile PHP, and then it passes the username to fetch the profile. Then we have another fetch for API messages, and then we have hello and debug, which we already saw. So what we can do now, as I said, let's go back to the target sitemap, and then here we can ask Burp again in the engagement tool to discover content. So let's do that. Session started sitemap, and see what it found. Found a hello. So it turns out that the Discover tool cannot parse, or is not smart enough to detect that those paths, the /API profile, is an actual path in the API. Because if we extend this one, oh, it has a profile. Oh, it has it. Another tool that we can use. Actually, let's keep on in scope, so we have less noise here. Another tool that you can use is the extension JS Miner. So we can run param miner to discover any kind of parameters in these new paths. What we can do here is test everything. And another thing also in the extension, in the JS Miner, run all check everything for JavaScript, because the paths that we see here, they are already in the JavaScript. So maybe one of those extensions is smart enough to detect it and maybe find new parameters. Okay, so while we are running these extensions in the background and try to see if we find additional paths, so additional paths or additional parameters for the endpoints, let's try to play a bit with the endpoints that we already know. So I'm going to focus on the login PHP, the profile, and the messages. And the main reason for that is that we already have some parameters here, so we can run some injections on those endpoints and those parameters to see if we get any other vulnerability related to it. So I'll send all three to repeater, and let's see what we have here. We can close this one, it's not relevant anymore. This one, we kind of made use of it, but I will just keep it as logs. And this one is messages. Good to name your tabs so it's easier to know which one of them is doing exactly what. And this one is, let's call it login PHP login. So at the moment we don't do anything with this, but let's try to do some intruder on this and on this and on this. And for the get messages, we can do something here. Add and the limit, and similarly let's run something like a quick fuzz or a full fuzz. Just something quick to see if they are vulnerable to any quick payloads. If we get something quick, if not, we start to investigate more. We have 400 requests on those. Let's make sure that they are properly encoded. Looks like we are encoding the payloads in the URL. If it's not encoded, the server might refuse our request, and we just run the attack for no reason. So this is the baseline request, and the baseline request returned us with some information, which are just some regular message, everything that we have already seen in the web interface. There's not much here. We start to see more of those 609. We have a different status code, 400. User not found, and the reason for that is because we passed the parameter, we got an invalid UUID for that. So let's let's try to filter out those logs so we don't have so many, and similarly as before, I will remove the 400 from the view. Now we are only left the 200 status codes. Don't have anything else, and then let's try to see if we find a different length. No, it seems that they all return the same things, even if we have a weird limit. So let's see. Oh, it seems like 600 and 600. So we don't find much with this intruder. I'll close it, discard. Then I will move on to the next one, which is the profile. We have a username Johan, so let's try to fuzz this similarly as before. Let's do a quick fuzz, and let's maybe try to load a list of usernames or common usernames. Let's try to see if we have something for username. I don't have a list for username, but maybe web content. Let's try to see here. Well, it's just here. Don't see any user. Pretty sure checklist has a user list, default users or something. Main the web services. Variables. What else do we have here? Checklist. Fuzzing. Oh, there was a usernames folder. Username, default usernames, top usernames. Yeah, let's use this one. Search, I don't know what this. Common admin. Let's do top usernames shortlist. How big is that? Okay, we have some things here. Let's run this. Let's run this fuzzing and default usernames on this endpoint to see if we find anything. So again, there's some 400 and they all are kind of the same length. We're not interested in 400 codes. Let's see if we find something. Okay, we found something different for admin. We find found some information. Send this to repeater. This is profile and username admin. We have information about the admin, like the UID, username, first name, admin. Doesn't look like much, but we started with the username Johan, which was ours, and just realized that we had the flag for accessing the first user. So let's write that down first before we move forward. I'll just delete that. Make a folder for flags and flag 1. I'll put it like here, and let's remember where it was. So it's this request. So it's good to save the whole request, because if at some point you need to get again the flag, or you need to report this to a client that you have found a vulnerability, it's good to have the whole context of how you found this information, instead of just giving the client, in this case it's a flag, but if you have found some sensitive information, instead of giving just that sensitive information, it's good to give the whole request and response. Otherwise you have to go back when you write the report to find again this information. So I'll save the request and the response in the cherry tree as well. Request and the response. And I'll just put the flag on top to be easier to find. Can we make this bigger? Yes. Very nice. Okay, so we found our first flag. Coming back to Burp. So what we were talking about was, initially we found profile of our own user Johan, and we found some information here, and then we found also username admin. So it's possible to give arbitrary usernames and then read some limited information about that. We don't get a password or a session or anything, but it's still good information, and it's always good to make a note of this. So I'll say profile admin for this, and I will save this information also in cherry tree. Actually, it is quite of a finding, but I'll put it in a folder called interesting, and then at some point I look through all these interesting things and see if I can combine them into some bigger finding. So I'll make it admin profile, let's say. The response. Oh, I really don't like to save JSON like that, so let's make it nicer. So let's say echo paste. I don't know why it doesn't want to paste. Say this and set it to JQ, so it looks a bit nicer. Nice. And the request also, just to remember where we found it. Okay, so we have a UUID here. Let's see if we can. If we look in the app itself, you can see that there are some senders and recipients. So what we can do is we create a list of all those people and see if we can read more information about their profiles as well. Similarly, how we did for admin, let's do the same for this one. So I will copy this one. It's the second. Messages. So it's the one from here. What we can do is extract it. Save this, pipe it to JQ, and then prep for sender. How can I make a regex rule for both? Let's see, maybe ChatGPT can help. Prep for two things. Syntax. So we have something like this. The pattern 1 and pattern 2. So let's say under and recipient. Okay, so now we grab for both, and let's say cut again with the delimiter of this and F3, 2, 4. Yes, and then we sort it unique. Okay, so we only have 3 new users. This felt like a lot of work to extract only 3 new users, but let's go back to profile, send this intruder again, and then we fuzz it with Charlotte and Alice. So we have Alice. Have a UID for her profile, Alice Smith, and we have one for Charlotte and Johan, which is ours. Let's copy those as well to cherry tree. So Alice admin profile. Profile and Charlotte profile. So we are starting to collect more and more information. It's not something critical at the moment. Of course it's not ideal that we can read this information about other users, but at the same time it's not something critical. What we have a UID, and the username is something that we already see kind of in the user interface. What else we have there? And first name and last name, it's not ideal to have, but it's not something critical that we can exploit at this point, and we have a sign up date. Let's continue to see what else we have in this repeater. We have the profile, we have the login. Let's do some intruder on this login to see if we can find maybe some injection attacks on this. It's hard to guess a new session and to move into another account. But we can try to see if there are any other injection here. Again, I will use the quick and full fuzz just for something quick. Let's start this. We have a 302, but this is the baseline. This is the one that we already know, so it's nothing uncommon. We have a lot of 403. 403 is forbidden. Let's see. Let's filter out the 400 codes. So that was the only thing. We didn't get anything else. We didn't get any 500, 300, except the one that we already had. So I'll close this for the moment. Let's go back to repeater, and one thing that caught my attention was that in the messages we have a UID, and what I like to do when I see a UID in a parameter is I copy it and I see if this UID appears in some other response or request in the application, so we can see that is it associated with some other endpoint, and if it is, maybe we can find other UIDs there, and we can bypass this what's called security by obscurity, because developers assume that just because it's hard to guess, we will not be able to find another UID. So let's search for this in the Burp history, and we can see it once here, which was already there, but you can see that the same UID appears also in the response of the profile for Johan. So what we can see from here is the user UID is used to read his messages, and since we can read more details about other users, we can get their ID, and then let's try to see if we can read their messages. So if we go back to profile, and we had another user, let's say admin. We have admin. If we go admin, we have the UID of admin, and then we can use this UID for, let's try to replace it in the messages. Okay, so now we can see what looks like different messages from what we see in our user interface with our user. So with Johan though, you can see, hey Johan, how are you? Hi Alice, I'm good. And we look at the API messages using the UID of the admin. You can see some messages about a system maintenance, the enterprise fixed, some discussion with the dev support. So now we have another user, dev support. Let's write this down as well. Dev support, and let's see if we can read more information about this one. Where was that? Profile, dev support. User not found. Let's say dev. Dev support So there's not much here. I'll just can't read details about user. Let's go back to Johan. So we have UID. Let's read the messages for other users as well, because we have Alice and Charlotte as well. So let's try to use their UID. So it's not here, it's in the messages. And one thing that I noticed, there is a limit here, so we can try to increase this one maybe like this to see more if there are more, so we are not limited by our request. So if we go for this, oh, we have another flag this time for which user is this one. Let's see which one is associated with this flag. So it was Alice. So if we read the messages of Alice by providing her UID for the profile, we can see that one of the messages includes another flag. Let's make sure that this is not the same flag that we have already seen before. And this one has 7 DF, and the flags has, what was the flag? CFA. So this is a different flag. This is flag number 2. So flag number 2 is related with the fact that we can read messages of another user by knowing their UID of their profile, and we find their UID by abusing another endpoint, which was the profile. So the profile is leaking the UID, and then we use this UID to abuse the other endpoint, which is the messages, to get their messages, because there was no way for us to find out this value if we didn't have the other endpoint, which was also vulnerable to broken access control. So first, the application leaked to us the UID of the user, which doesn't seem much, but since the other endpoint was also vulnerable to broken access control, this allowed us to use the information from the profile endpoint into the messages endpoint and then read the messages of another user. So this is one way to chain together different vulnerabilities, and to also pivot from your user to another user, because at this point we can see what other users are talking about without even having access to their account. So let's save this flag. I don't remember if I saved it. No. Let's save this flag. Flag 2. And let's save also the request and the response, just to have context on where we found it. And here. So now that we found this one, let's try to see if we can, where can we move from here, because we still have one flag, and at this point I feel a bit stuck on how do I move to the next flag, because it feels that we are kind of done. So what we can do is try to read the messages of all the users and see if we can find anything there, because we are kind of running out of endpoints. Let's go here. We tested this one and we didn't find any injection. We tested this one and we saw that we can read the UID of different users, and we tested this one and we saw that we can read the messages of different users. So let's try to read through the messages of each of the users available and see if we can find anything there. Otherwise we have to go back to the Docker, and what else do we have here in the enumeration phase. we have the Docker, which is the PHP. We have the Docker file, and then maybe we can look again through the logs and start to do more enumeration and file folder brute forcing with larger lists to try to find additional attack surface. But I feel that we are not yet done with reading the messages, so let's make sure that we exhaust all the paths that we have here before we move further. So what I feel that we are missing at this point is we don't have a complete list of users that we can enumerate. We have this list, but it's quite a few users. So I'm going to copy this and say users here. I have this, and then I have Johan, which is the admin. There was dev support, Alice, Charlotte, Johan, admin, dev support. Do we have anyone else that we are missing? Let's go back here, the messages, because these are messages of Johan, and let's see, messages of Johan, messages of admin. So admin has this UID. I'm going to paste this here, and I'm going to take all these messages. There is a live API enterprise v2 Swagger file. We might have a path here. What version is still compatible? What I'm going to take all these messages and I'm going to save them here. Can we compile this? Can we merge them together? Not sure. Let's x2 messages Johan, and then let's make a messages admin. And what else do we have? We have messages Alice and messages Charlotte. Alice. We get her ID and we read her messages. Save those as well. Messages Alice. And we have messages Charlotte. Let's read her profile. And we get the ID. And we read her messages as well. You can see another recipient, Jimmy. Let's take this. Charlotte. And there is a user Jimmy, which we didn't see before. Hey Jimmy. Let's read his profile. Oh, user not found. Did we miss something? Messages. Jimmy, Charlotte. There is a Jimmy here in the recipient, but says user not found. Jimmy. It's just one. Okay. Let's make a note of that. Unique profile. Okay. Right, support. Okay, let's read through all those. Let's parse all these messages and see what information we want to extract. So I want to see if we can extract more senders and recipients. Maybe we missed some new users, and then let's try to extract all the messages from those, just the messages, not the JSON. So let's say for I in ls msg, something like this, do echo y done. So this should go through all the files, and what we want to do is do the same thing as here for each one of those files. So instead of cat x, I will just read the file that each one of those files one by one, and then extract the recipients and sort them unique. So let's do this. We sort this here. Okay, and now we can see that we have admin, Alice, Charlotte, dev support, Jimmy, and Johan. There are no new users in this. Everyone we already know, dev support and Jimmy we already saw that we cannot read their profile for some reason, and for Johan, Charlotte, Alice, and admin we have already read their messages and their profile. So let's try to print all the messages and then read one by one. Yeah, let's do this. So this is the conversation between everyone. Almost done by Emily, blah blah blah. Don't tell our clients about it, tell them to use the new one. Great, Jimmy. There's something, Alice, nothing, reminder, system maintenance, square flag, this already read, sure. The old version is still up for backward compatibility until end of Q4. Yes, I fixed it, it will be around. And there is a path, yes, it's live at API Enterprise v2 with updated Swagger file. So let's try to access this path. Yeah, we can do it directly here. Something like this. It says no found. Source not found. So there is a mention of Swagger file, so maybe we can do some fuzzing on this. Let's put it here, the injection point. Then I don't know if we have something for Swagger files in the sec list. Let's try to find. I have to Google this one. Let's say at least Swagger file. Swagger. Code. Doesn't find anything. How can there be no Swagger references? Swagger txt. There must be some. Let's try here. Swagger. Swagger. Those are quite good. That's, which one is it? API endpoints.txt. Ah, it's a small list, so we can copy it directly from here. So let's use this one for the intruder, and I'm going to paste it here. So we have some Swagger references here. Let's try to see if it finds anything. And we don't want to URL encode, because it will encode the slashes in the paths, and then it will throw an error maybe. So let's disable this one and start again. 40444 the 400s. This won't work. Response 400. Let's hide this. Oh, didn't find anything. Let's try to see again. We missed something. Fact. Nope. We do. Try to see again. It's live at API v2 with updated Swagger file. Do we have to remove the slash? Oh, Swagger. Swagger. Listen. YAML. Oh. Let's see what other files do we have that may contain Swagger references. Swagger paths. Either. Where do you look at this? Let's try this. Maybe it's a different path. API enterprise. We remove this. What did the guy said? It's live at /v2. It's not. Let's try to run again. Otherwise, we can also try the quick hits one. Usually, this API endpoint should have the Swagger, but maybe it's another one. API endpoints, web services. So you have something here. Swagger, yeah, API docs. You can try this one also. Don't think it will find more, but can this one is larger. It's much larger. It's a bit too much. Swagger. Actually, let's extract only the Swagger path from here. Okay, Swagger list. Copy this, paste it here. So we don't want to we want to be case insensitive in case there are some different paths that are not that are capital letters or something. We don't want to miss those. Let's try those as well. Did we find anything? It's good. Let's remove this. we found something slash v1. This API version is available only for backward compatibility. Please use version 2. Okay. So we found something in version 1, but where is the version 2? Is everything the same? Yes. So let's make a note that we found something for Swagger version 1, and there is another reference to version 2, but we didn't find the version 2 one, and the version 1 doesn't give us much. I'll make a note of this. So let's create a new node. Swagger v1 for version 1. This is the request. Let's see what was the response. This API. And then the reference to v2. Let's see, what does it say? We have this message, and we have the other message from here. We have two references, and then we have a path here, but we didn't find the actual Swagger file yet. So maybe with the new paths. Let's try these paths. I'm going to close some of those because there are too many. We want to exit yes. So let's go back to version 2 and let's try to do more fuzzing here. Maybe these ones. Let's try. $400. This URL encoded. No. Let's try quick hits maybe. Here. Quick hits. Let's do again. Don't want to see 400s. I think we hit the rate limiting here. Let's set gateway. Let's pause for a second. Maybe we can also extract the Swagger files from the quick hit so we don't run so many. Let's see if that's possible. Copy this. Swagger UI, that's the only one. It's not much. Is it v2? Oh. So turns out we didn't find anything yet in the v2 one. let's try to we will try more lists because there seems to be a reference to it, but we just cannot find it. Maybe something from the default burp that has it. Let's try to see what is there. In the intruder, let's see, one of those lists has it. Directories, file names. Let's see what else is here. Fuzzing, SQRSEC, letters. Let's go with file names, long maybe. I don't see anything related to, but let's try to run this one. Then in the meantime we can try to search for some more maybe better lists. Let's see, v2, is it v2? Swagger, is this a path? No. It's something that is known. Let's try to see this. Open API specification. Swagger. Open API paths. And test. Thank you. Looking for paths, no, something like this. Swagger.json. Fantastic. Auto Swagger, what is this? Discover, parse and test unauthenticated endpoints using Swagger. Discover? Can we discover endpoints with this? Discover faces. Tries known paths such as, okay, let's see, direct specific brute force, attempts to list Swagger / open API etc. Let's see what lists this one has. Swagger.yaml. Where are the lists? This. It's hard coded. Swagger UI paths, direct paths. Okay, these are some good things to try. Let's get those. Didn't copy it. Parse it? No. Wait a second. Why is it an error? There is a comma here. No. there is some backslash. Let's do translate backslashes with nothing. Set2 must not be empty. Why? What's the problem with being empty? Put a space. No, but we need the what's the problem? Objects must contain key pairs. So this is just a list. This is just a list. It's not a JSON. Protocol. What do we want to do here? Translate commas with new lines. Yes, and then we want to extract only the paths. F. Oh, delimiter is -f2. Yes, and then so it's unique. You have new paths. You have new paths. Let's try those. Clear, paste. Let's ignore this. Like this. Let's see if we find something with these new ones, and then we have, where was that? We have also these ones to try. Otherwise, running out of ideas. Feels like a rabbit hole. Remove the 400s. Nothing. Didn't find anything. One more list to try. So we tried this one, and let's try this one. Copy. Oh, this is terrible. This is terrible. Echo. And then we want to do the same thing again and extract paths. More Swagger files to try. Or maybe we should put you see here they have v1, v2. So let's try once with our own v2 and once to do it with their own v2 if we don't find anything, because they already have v2, so we don't have to put ours as well. But let's try first. We already have v2 here. Clear this, paste. Don't want URL encoding. Let's try this again. And oh, status 200 response, and got something in the open API.yaml. The other things are. The other things are 4.4, but this one finally returns something. So let's try to look into what's this. Looks like a open API Swagger documentation. So let's try to response flag.php retrieves the final flag, returns the final flag using the valid API key. API key contains from the API key obtained from API. Let's try to. I think we are on the right path. Example flag. This is the path. So we have one endpoint flag.php, and we have one path API key.php. Generates the API key. Returns the API key UUID format for authenticated users. There's no security on it, and it returns a JSON object which contains a UUID key, and then the /flag one takes a parameter API in the query, and it returns. Actually, we can open this in the Visual Studio Code to see it much easier. I assume. Let's try to do that. So I just save this one. Swagger v2. So we have the request. And then the response, Swagger 5. Let's copy this. It's an Open API version 3. And I wonder if we can put this in some API keyword. Swagger editor. Let's try this. What is happening? Paste it here. API for accessing secure enterprise resources. Oh yes, this is much easier to read. So what we have to do here is, let's try to send a request to API key. Don't need any parameters. Let's copy this. So it's API enterprise v2 / API key .php. Repeater. This. Unauthorized. Upgrade to an enterprise account to get access to the API key. Okay, let's try the other endpoint. /php invalid API key, but we need to pass a parameter. API key required. API key obtained for the /API. Let's try to add this. And API key is equal to 3. Not found. Maybe it's like this. Invalid API key. Invalid API key, but the previous one set a different error. No, this is invalid API key. And this one is invalid API key. So the flag requires an API key, and the API key endpoint, what was it? API key.php. This one is unauthorized upgrade to an enterprise account. So one, let's see what we have. We have v1 endpoint, so this API version is available only for backward compatibility. So what we can try is try the same endpoints on the old API, on the old version. The old version is hosted at /v1, so we can try this. API key, this valid API key. If we don't provide one, valid API key about the API key v1, API key unauthorized. Upgrade to an enterprise account to get access to the API key. Interesting. So v1 doesn't get us the API key, and unauthorized, but something different. Is this cached? Upgrade to an enterprise account. V1. So let's try another thing. What if we test? So we have the OpenAPI YAML. Let's try that on the Auth. Not found. So we have the flag. Does this one work? Error, invalid API key. Valid API key. Unauthorized upgrade to enterprise account. What about flag? Valid API key. If we put can we try here? So we can try. Let's read again the documentation. Returns the so API key.php returns the new API key UUID for authenticated users, and it should look something like this. If we try this one, if we try the exact value from here, flag and API key is this, valid about v1 flag. No. Authentication required. Can we do this? Does this work? No. URL enterprise API key flag. Are we missing something? Enterprise v1. Let's try this again. TCP/IP. Okay. What happens if we do this? Upgrade to an enterprise account to get access to the Where do we get an enterprise account? How can we get an enterprise account? Let's look at our own profile. Johan. What is happening? Unauthorized. Maybe our session expired. Let's try to, because we used to see this. Okay, maybe our session expired. Profile. Let's log in again. Oh, we got a new session. Let's try to read again our UUID. There is no reference about having an enterprise account. Let's go again to V2. enterprise, and let's use the new session. Unauthorized upgrade flag. Valid API key. What do we want? Valid API key. Key. Let's try to read the new key. Oh, so the problem was that our session expired, and when we tried to read again, when we tried to access the old version, the one that was referenced in the messages. So where was that? Here. This API key is available only for backward compatibility. So when we try to access that with our session, the session has expired in the meantime, and we couldn't access it. But if we try with the new session, it's actually possible to read the API key from the old version of the API. So now we have an API key here. Let's try to read it from the flag and see what was the parameter. Parameter was in the flag. Parameter was API key. So API key equal this one, SQRSEC flag. So now we got the third flag of the lab, and the issue in this case was that the patch was applied, because if we try to read the flag from the new API, the patch was applied only to the version 2 of the API. Here authentication is actually working. If we test, let's try to do API key PHP. So in the version 2, our session is actually checked and it says that we are unauthorized, but in the messages that the users were exchanging, we could see that the old version was still there for backward compatibility. And if we do the same request on the old API, the version 1, we can actually get the API key. And then using that API key on the old version of the API, version 1, we can read the flag from flag.php, and API key is this. So now we got the third SQRSEC flag. So let's save this one and let's submit the flags. Where was that? Flag number 3. And we got it from here, and let's set the request also. So now what we have to do is combine those 3 flags and submit it on the portal. Flag number 1, hashtag flag number 2, hashtag flag number 3. So if we go back to the SQRSEC labs, we go to our profile, challenges, SQRSEC lab, we get the 3 flags separated by hashtag, submit that, and we got the points. That was it. Thank you very much for your attention, and I hope you enjoyed the walkthrough. It took more than I wanted, but you could see that problems can come all the time, and you could see like when things don't work as intended, you can still try to find ways around it, and how you can parse the logs, how you can work around errors, how you can debug them, and so on and so forth. So again, thank you very much for your attention, and I'll see you next time.